During my talk, I will provide you with some background on navigation in Brownfield apps and why it might be important to you. Although, let's start with a few words about me. I'm Michał Chudziak. I live in Wrocław, and I'm a lead software engineer at Callstack. You can find me on GitHub, Twitter, and Medium under the handle shown above. I will start with a simple question. How many of you have ever tried integrating React Native into existing native app? Okay, not very much. I hope you will find some inspiration to try it out after the conference. But first things first. What should you do if you want to start a Brownfield project? Surely you will need some motivation and outstanding Googling skills. And eventually, you'll land on the React Native website. It's a great source of knowledge. The topic is well explained, and everything seems to be pretty straightforward. You can navigate between the tabs to choose the target platform and convenient language. You will learn about the key concepts and tread through a very nice step-by-step tutorial. Finally, you will end up with something like this. A simple native app with a React Native screen embedded inside. As you can see, it's not flawless, and there's a short white flash caused by the loading of React Native. It's only one of several problems that may occur in your further Brownfield experience. While it's okay to develop the app this way, having any flashes in production is unacceptable. Generally, the app works, although there are a few matters. It's okay to have just one screen in React Native, but what if we need to integrate the wall experience? How we'll connect the navigation inside the React Native module and in the rest of the app? Is it as simple as installing React Navigation or any other navigation library? Well, it is, but not really. It would be a wide-eyed approach. As soon as you start playing with it, you'll run into a few more questions. How to reuse the same instance of React Native between the screens? What to do with the native gestures? What to do with the Android back button? How to hide the native header? How to go back to the native screens? Yeah, maybe not in this order. Well, that's a lot of questions. It turns out that it's not going to be a piece of cake. Although it's not going to be as hard as you think as well. You just need to understand a topic thoroughly and choose the right tools. In order to do that, let's begin with some theory. I will start with explaining basic building blocks in native development. Those are going to be crucial for a deeper understanding of mentioned issues and will allow you to deal with them in the future. Speaking of iOS, I will go through the key components related to its native navigation, at least until UIKit is a standard. In the beginning, the simplest building block, a view. A view object renders content within its bounds and handles any interactions with that content. UI view is basically what's rendered by React Native's view component on iOS. They can be nested inside other views to create view hierarchies. A parent view may contain any number of subviews, but each subview has only one superview. Views are good with drawing and interactions, but they don't tend to go beyond that. UI view controller is an object that manages a view hierarchy for your iOS app. Just like views, view controllers have their hierarchy. The root view controller is the anchor. Every window has exactly one root view controller whose contents fills that window. Presenting a view controller replaces the current one's contents with those of a new one, usually hiding the previous. You can present one view controller on top of another by calling a present method. When you present a view controller, UIKit creates the relationship between the presenting view controller and the presented view controller. Often in the apps, we need to have a navigation stack that is not modal. Luckily, UIKit comes with a UI navigation controller, a container view controller that manages one or more child view controllers using an ordered array, known as the navigation stack. The first one in the array is the root view controller and represents the bottom of the stack. The last one is the topmost item of the stack and represents the view controller currently being displayed. I hope you've got some overview of iOS navigation components now. I think we can jump into the Android stuff. Again, I will begin with a view. View class represents basic building block for Android user interface. A view occupies rectangular area on the screen and is responsible for drawing and event handling. Just like on iOS, we need some container to display a view. This is where the activity class steps in. It's a crucial component for an Android app. An activity provides the window in which app draws its UI and controls its behavior. Each activity should have a content view to draw content. setContentView method sets the content to the activity, sets the content of an activity to an explicit view. This view is placed directly as a root into the activity's view hierarchy. It doesn't have to be a single view. It can itself be a complex view hierarchy. Nowadays, it's more common to work with a single activity. Even if your app is more complicated than just one screen, there's a way to design your navigation stack without having to have multiple activities, thanks to the fragments. You can think of a fragment as a modular section of an activity, which has its own lifecycle, receives its own input events, and which you can add or remove while activity is running. Each fragment has a view that represents drawn content. Not that long ago, Google has come up with Android Jetpack, a set of components that helps Android devs with their daily work. One of these components is a nav controller, a component that orchestrates swapping of destination content in the activity as users move throughout your app. The navigation component is designed for apps that have one main activity with multiple fragment destinations. The main activity is associated with a navigation graph and contains a nav controller that is responsible for swapping destinations as needed. Well, I promised to wake you up, but instead you've got all this terminology. I'm sorry about that. An overview of these building blocks is important, and now we can focus on more practical stuff. I will explain how to integrate React Native apps seamlessly with native navigation stack and create the best user experience. There are a few key things to take care of while integrating React Native part to the native app. Long story short, we have to make it feel native and not to allow users spot the difference while changing experience back and forth. The first thing is the transition. We need to have a smooth transition without any flashes. React Native has to be ready, and our module ought to be rendered while pushing the screen. Take a look at these animations. They are smooth, no matter if we go to Aaron's screen from native or pushing another JS-based screen. Another thing we cannot forget is the platform compatibility. Our users are used to the platform-specific gestures and hardware buttons. Hence, they are expected to behave the same, no matter if we are using React Native or the native. We need to make sure that when the user does the swipe back gesture on iOS, he's taken to the relevant screen. It's the same if user is using hardware back button on Android. Having both navigation stacks in sync is a must-have. If you wonder how to achieve it, I have several tricks for you. Following these steps will allow you to create a smooth experience for your app consumers. A first step would be to design a JS navigation stack. This step could be omitted if you have a single React Native screen to be rendered within the app. Looking from a high-level perspective, JS navigation is similar to what we experience in native. However, implementation heavily depends on the library you will choose. From my experience, React navigation is a very convenient choice while integrating React Native to the Brownfield app. While it seems to be easier to go for a native-based navigation due to the similar base components as in native realm, apparently it's not. And the integration is more complex than you would expect, and it differs with every library implementation, while most of the further facts are relevant for any JS-based navigation. Let's take React Navigation Stack Navigator as an example. It provides a way for your app to transition between the screens and manage navigation history. It's similar to how UI Navigation Controller or Nav Controller works. Your app pushes and pops the items from navigation stacks as user interacts with it. And this results in the user seeing different screens. Following diagram represents a simple JS component tree for a Stack Navigator. Also, you can embed more Stack Navigators into Stack Navigator, designing more complex navigations. Of course, it's not the only way to design a navigation flow in your app. You can also use tabs or modals, and all of these has their equivalents on the native side. Implementation itself is pretty straightforward. You need to create a navigator of your choice and design a navigation flow however you like. There's a nice guide in React Navigation docs. You can follow that to learn more. JS Navigation Stack itself isn't that important for wall integration. What's most important is the transition between those two realms. In order to keep it fluent, we need to initialize React Native bridge up front before pushing the first view to the stack. A common mistake I've seen is to let React Root instantiate the bridge for us. It is wrong, and you need to instantiate a bridge and load React Native in a convenient moment. You will be the one to decide if it's an app startup or a different moment. Just don't do it on push. This way, you will minimize the chances of having any content flash. When the bridge is instantiated and the bundle is loaded, remember to keep the created instance. You can write a simple singleton to do it for you or choose a different way. Just try to avoid recreating the instances. When you've got your instance and a JS screen, it means that you are ready to connect it with the native app. Start from registering the component in JavaScript. This has to be done for every React Native app, but remember that you can register multiple entry points with app registry. Basically, you need to provide a name and a root component to be rendered. Remember the chosen name. It will be used to render a relevant component on the native side. Now it's a perfect time to render a native view. On iOS, it's going to be RCT root view, and on Android, it's a React root view. Just place them somewhere in your native hierarchy. You'll probably need to create a separate view controller, activity, or fragment, but it's also possible to embed just a single view. Finally, make sure to use previously created instance of a bridge. It will make your RN app appear in before you blink an eye. As we thread through the integration, we'll most likely meet the previously mentioned issue. Our users are used to the native gestures and hardware buttons on their devices. We shouldn't ignore this fact and fix this behavior. Take a close look at these devices. It doesn't matter if we are scouring through React Native screens or going back to native. Everything works as it's supposed to be. Users can use their app without seeing a difference. To achieve that, you will have to toggle and override relevant fields and methods in your activities and view controllers. Writing a native module to toggle that from JS seems like a good idea. All of these will bring very good user experience and make your Brownfield app look and feel native. Of course, writing these few lines isn't enough to achieve all of this. You will still have to write your own instance storage, view controllers, activities, or fragments, and the native module. It could definitely take some time. Unless somebody does it for you. And guess what? Somebody has already done it. Today, I'm proud to present React Native Brownfield, our brand new library that contains a handful of helpers to make your life in Brownfield easier. We've done several Brownfield integrations in the past, and each time we had to write a few helpers and repeat the code. We don't have to do it anymore, since now it's embedded into one library. A library that is flexible, easy, and useful. This type of integration differs depending on a platform or a language. You don't have to worry about that. It is compatible with any native language and navigation pattern. let me present you some key features of this library. Those features will cover all of the issues mentioned before with just a few lines of code. In the beginning, a method to simply start React Native. Calling that will load your JS bundle into memory or fetch it from packager. You can call it whenever you want, on the app startup or later while presenting some screen. There are no restrictions. We are using some defaults for entry file, bundle name, and other React Native internals, but we don't want to force them. You can easily customize it for your own convenience. Remember when I told you to store an instance of a bridge somewhere? We've got it covered for you as well. We provide you an easy-to-use storage that stores a bridge after you initialize it. It doesn't matter which navigation pattern you follow. We prepared native containers. Those are the building blocks I mentioned before. They allow you to place React Native screen in your navigation hierarchy just by passing a module name into the constructor. After installing our library, you'll be able to control the back gesture, hardware buttons, and the native navigation stack from JavaScript. You just need to call the exposed methods imperatively. Those are just a few features we've prepared for you. I recommend you to try it on your own. In the near future, we are planning to release a separate React navigation navigator. That's going to make it even easier for you to integrate Brownfield apps with React navigation. The other thing is a set of plug-and-play build scripts to decrease the entry level for Brownfield apps to the level never reached before. It's available now on GitHub and NPM. Just go to Callstack GitHub and search for React Native Brownfield, or use the link provided above. The project is right after its first release. If you have some ideas on how to develop it, or want to help us maintain the library, feel free to submit a PR. We are inclusive, and we accept all contributors. If you want to know about the upcoming plans and updates, make sure to check out our blog and follow us on Twitter. That would be all from my side. Enjoy your coffee break. Thank you.